guys, so today I'm going to go over how to do the calorimetry lab. So the purpose of this lab is to identify an unknown metal. Every substance has its own unique specific heat, so if we can use our lab data to calculate the specific heat of our unknown, we can compare it to a list of known metals, and based on its specific heat, we should be able to figure out which metal it is. So the first thing that we're going to do is take our metal, and we need to get its mass. So I'm going to pour my metal into a zeroed weigh boat. And the mass of my metal is 89.19 grams. 89.19 grams. Alright, so I'm going to take that metal and I'm going to put it back into my test tube. And I'm going to clamp my metal onto a ring stand. And then I'm going to lower it into a beaker of hot water. Alright, so I'm going to let that metal heat up. We know that heat always flows from the hotter object to the cooler object. So that hot water is hotter than our metal, so heat is going to flow from the hot water into our metal, causing it to heat up. So while we're doing that, we can get our calorimeter set up. So we are going to use a styrofoam cup for a calorimeter. The reason we want to use a styrofoam cup is in order for this to work, we're assuming that all of the heat that is going to be lost by the metal is going to be gained by the water. So in order for that to occur, we want to minimize the amount of heat that is lost to the surroundings. So styrofoam is a good insulator, so it works really well for this lab. In my calorimeter, I'm going to add 100 milliliters of water. 100 milliliters of water has a mass of 100 grams. And then I'm also going to need an initial temperature of the water. The initial temperature of the water is 20.7 degrees Celsius. 20.7 degrees. Alright, next, I'm going to place my thermometer into the unknown metal, and we want to make sure that the temperature of the metal is at least 90 degrees before proceeding. So the next step is we're going to take the initial temperature of the metal, and that's going to be the temperature of the metal right before we pour it into the calorimeter. So what I'm going to do is I'm going to take the clamp off the ring stand, and I'm going to pour the metal into my calorimeter. And remember, we're trying to limit the amount of heat energy that is lost to the surroundings. So I'm going to cover it with a piece of aluminum foil to try to trap all of that heat in the calorimeter. And then I'm going to get the final temperature. The final temperature of the metal is going to be equal to the final temperature of the water. Heat continues to flow until both objects reach the same temperature. So heat will stop flowing when the temperature of the metal is equal to the temperature of the water. Alright, so we're going to take a temperature reading right before I remove the metal from the boiling water. So the initial temperature of the metal is 94.4 degrees Celsius, 94.4. All right. Got the metal in my calorimeter. I'm going to cover it with the aluminum foil, and we're going to get our temperature reading. right, the thermometer finally reached equilibrium at 23.6 degrees Celsius. So final temperature for both the metal and the water is 23.6 degrees Celsius.